Hi, everyone, and welcome to this talk about secure LLM app deployments. Basically, we're going to discuss about strategic and tactics to try to assess the cybersecurity risks around LLM-based applications. For those who don't know Giskard, we are a company that is specialized on quality assessment for machine learning models, meaning that we test machine learning projects, both on the performance aspects, but also on the cybersecurity aspect and on the compliance aspect as well. And for this, we have a bunch of products, let's say, which are an open source Python library that allows you to test machine learning models in order to detect those kind of issues. And we also have enterprise products as well, such as an AI quality hub for LLM to audit LLM projects, and an AI compliance hub in order to edit project documentations to make sure they are in line with the latest compliance laws. And finally, nowadays we do lots of services related to LLM red teaming, so basically pen tests for LLMs. And that's why I'm going to discuss about the vulnerabilities you can find in such models. So we'll start by defining a few terms before I give you an overview of the risks. And once you have the risks related to LLMs in mind, then we can dig a bit deeper into what is LLM red teaming and what techniques you can use to mitigate those risks. So first, a bit of terminology. What is AI red teaming? So first of all, you have to keep in mind that AI red teaming is a recent word. We saw the emergence in that word in 2023 across various White House communications, where they announced in May 2023 that the recent rise of Gen AI models had raised the need to have a public evaluation event at DEF CON 2023. The red teaming term wasn't used at that time, but in fact, in August 2023, we can see at DEF CON that the event was named a red teaming event. And finally, the, let's say, official AI red teaming definition comes from the Executive Order on Safe, Secure, and Trustworthy Development and Use of Artificial Intelligence, which was published in October 2023. And in this communication, AI red teaming is defined as a structured testing effort to find flaws and vulnerabilities in AI systems, using mainly adversarial methods to do so. So first of all, for those who might have a background in security, you have to see that AI red teaming is a bit different to classic red teaming when it comes to cybersecurity. And basically, AI red teaming is an umbrella term for kind of all the risks that can be linked to the usage of Gen AI applications. Talking about Gen AI, I think most of you will be comfortable with that word, but for those who don't know, so why do we target specifically Gen AI and what is Gen AI? So first, you have to keep in mind that the attacks on machine learning models are not new. Early research started like in the early 2000s, 2010s, where we saw the emergence of the first adversarial perturbations, so adversarial attacks, in order to make classification algorithms fail. So basically, we're trying to filter a small perturbations in the model inputs to make those models fail. But that field of research has been very hypothetical until the recent acceleration when it comes to machine learning usage in our daily lives, and until basically the late 2020s, when people realize, for example, that they can lure automatic cars by just putting some stickers on road signs and trigger them then to crash, for example. And consequently, since the people realized that AI security was actually a practical problem, in the early 2020s, we saw all big companies starting to have AI red teaming teams, and we saw the emergence of the first security frameworks specialized on machine learnings, with the operation, for example, in 2020 of the MITRE Atlas framework. So for those who don't know MITRE is a specialized organization, is an organization that is specialized on security and designs specific frameworks in order to audit all the kind of possible cybersecurity attacks and strategies you can have. So machine learning model cybersecurity threats were not very considered until the new trend in machine learning model, which is Gen AI. So generative models are extremely recent. Just to give you an overview of the chronology and how fast this part of machine learning has risen. GPT-2 actually dates back to 2019, and the main models we know now when we think about Gen AI appeared only in 2021, 2022, with the release of DALL-E, Midjourney, Stable Diffusion, and ChatGPT, for example. And so Gen AI, exactly. So what make those models different from classic machine learning models, and why are the cybersecurity issues on the model more important to check than for classic machine learning models? So first of all, we have to go have a look at traditional machine learning, so what we call discriminative models. So if you take those models, such as classification algorithms, what you're trying to predict is a few labels on the target column based on an input space that is pretty large, which is a bunch of all the features you have to describe some observations. So in that case, well, actually, the output space of the model is pretty limited because it's only a few classification labels. So everything is pretty controlled. Now arrives Gen AI, and in Gen AI model, what you're trying to do actually is generate data based on the distribution. So it's a bit like trying to generate like the whole input space of your previous discriminative models. Basically, you sample outcomes from a probability distribution, and the input the model takes usually is a prompt, so natural language, a few sentences. So in practice, you have, as it's natural language, you have a very, very huge input space that can go in more or less every direction. And you have a very, very large output space. So basically, the model is able to take more or less everything as an input and output more or less everything. And that's why Gen AI applications are particularly risky. It's because in the middle of those huge input and output space, you have a Gen AI model that is on top of this very, very complex, so that will often be a black box. From time to time, you have access to the model, so you can consider it a white box, but those models are so complicated that basically you have a problem in which you have to assess the security, where you can have everything that enters a black box, something that happens in this box, you don't know what happens, and everything that can come out of it. And so that makes a huge attack surface when you try to attack Gen AI models. Once again, you're not only testing Gen AI models, you're testing application based on those models. So as they are application, you have all the traditional software issues that you have in classic software engineering. You can combine that to all the traditional machine learning issues. So model extraction, for example, trying to extract the weights of a machine learning model. You have adversarial machine learning, so trying to generate an input that will lure the model and make it fail. So those are already two huge attack surfaces. On top of that, you can add the fact that as those Gen AI models are meant to be general purpose models, you don't know exactly what the usage is going to be. So you have an increased ethical risk when it comes to using these models. And as a model or general purpose model, you don't know what people are going to use those models for. So the risk surface is hard to define and extremely large. On top of that, so the attack surface is huge, but when you're trying to define the risks, defining those risks is complicated as well, because on one hand, you have all the security classical risks, such as data poisoning, data security, model evasion. So those are security risks that are pretty well identified. But on top of that, because of so the general AI purpose of those models, you also have a bunch of risks that are linked to AI safety and responsible AI, such as toxicity, generation of harmful consent, of unsafe code, hallucination, especially on regulated markets. And those two kinds of risks blend together. So people tend to think of defects in machine learning as cybersecurity vulnerabilities. So you have kind of a bunch of risks that are mixed together, which make risk assessment more difficult with generative AI applications. So that was for the risk part. And then what happens on the threat actors? Because when you audit security, basically you assess some kind of risk based on some kind of attack scenarios. And when you look at the actors, you can find, once again, all the classic actors from cybersecurity. So nation state actors, cyber criminals, competitors, so people who have basically huge technical and financial means. But on top of that, machine learning models and Gen AI applications also made it easier for other kind of personas to attack your machine learning models. So you can have AI researchers, so people that are more experts in machine learning, and you can have all the tech enthusiasts, tech journalists, Twitter people who just want to output and have a bad output on your model to just take a screenshot and leak it. And you can as well have typical users that just use, for example, a chatbot on a regular usage, and the chatbot hallucinates or generates harmful content. So you have a whole new bunch of actors and threats when assessing the security of Gen AI applications. So we covered a bit the technical risks, but we didn't talk about the practical consequences. Basically, the consequences of those technical risks will really depend on the use case. Is your chatbot open to the public? Is it internal? But you can have four main categories of risk when assessing the risk of a machine learning project. First one is the reputational risk. I think you all have in mind the DPD scandal, in which DPD realized a chatbot that was swearing, cursing the users, for example. That led to reputational damage for the brand. You can have legal risk as well. You can have some example of copyright infringement. You can have some other legal risk on highly regulated sectors, such as financial sector, for example. If you make some investment recommendations, that can be something that is highly regulated. You can have some data security risks. We've seen some data leakage, for example, from ChatGPT agents, some from Google Bard, when data was leaking between multiple user sessions. And finally, you have what I would call the operational risks or service disruptions. For example, let's take a chatbot. If you manage to perform a denial attack, a denial of service attack on the chatbot, that can disrupt the way you do business and the way the project works. So those are the four levels I usually use when assessing the business-related risks of a project. So before closing the part on risk assessment, let's just go over a few misconceptions people might have when it comes to AI safety. The first one is being that AI safety is only about existential risks. I think we've just seen my previous example that the risks have become practical now. People also tend to think that more powerful models like GPT-4, for example, are safer. It's not the case. They are still exposed to the same kind of vulnerabilities and risks as classical machine learning models. They are just better on academic benchmarks and a bit more robust, but you still have the same vulnerabilities. And keep in mind that in security, the zero risk level doesn't exist. So they have the same vulnerabilities. They're just better on benchmarks. Last misconception is that safety and security problems can be solved by foundational model providers. It's not the case. Most of the risk when it comes to machine learning are based on your use case. Are you working, for example, on a regulated environment? Is your chatbot open to the public? This is not linked at all to your Gen AI provider. So once you have a few ideas of what are the risks, now let's cover a bunch of techniques to try to identify those vulnerabilities and see how we can fix them. So how to do AI red teaming in practice? So first of all, you have to keep in mind that when I'm talking about AI red teaming, there's two different kinds of techniques that I will put into this field. You have on one side manual red teaming, and on the other side, automatic red teaming. Both these approaches have their pros and cons. On the manual side, that approach needs people with various backgrounds to test the model. You need on one side technical experts in order to test specific vulnerabilities with so a list of technical vulnerabilities in mind. But you also need to test your models, for example, against hallucinations. So you need business experts who will know all the use case related edge cases in order to test the AI model on those edge cases. And that makes manual red teaming more costly than automatic red teaming, but of a higher, let's say, quality. The auto red teaming allows you to probe a huge surface approach in a very cost-effective way. You can test a whole bunch of vulnerabilities at a time, but you can't go deep into the red teaming techniques because those are automated tools. So it's nice to use both in tandem. There's no silver bullet when it comes to red teaming tooling. And so once you know what kind of tools and techniques to use, the way red teaming works to me is working in a multi-round strategy. When first you use automated tool to probe the risk surface, you identify a few harms, and then you spend time manually red teaming those risks. Of course, your technical people are going to need feedback from the business experts. For example, when you test hallucinations, you might not have the business knowledge in order to assess it themselves. And there are often business stakeholders who know the business risks, and that will allow you to evaluate the criticity of the detected vulnerabilities. So you often iterate, find a bunch of vulnerabilities, qualify them, and then choose where to go on the next iteration. Now that you see how we're going to work, what are the practical LLM threats? So first of all, do not try to make a threat list by yourself if you're trying to audit your projects. The attack surfaces are huge, so they are specialized actors that build frameworks in order to assess as exhaustively as possible the risk surface. So I would encourage you to use specific tools like the OWASP Top 10 or the MIT Atlas framework, for example. Those actors list all the kind of possible risks, how to exploit them, and what parts of your applications they target, because a specific risk might be exploitable on various parts of your applications. So use such frameworks to have an exhaustive list of what to check. Then once you know what vulnerabilities to target, how do we attack an LLM? So first of all, we have to dig into how an LLM works. So basically, you have to keep in mind that LLMs are just text completion algorithms. They take a text as an input and they predict the next word. And if they want to put a phrase, they repeat that process in an autoregressive way. So an LLM is just a text completion algorithm. Then once it's trained, we fine-tune this text completion black box to make it available, for example, to work on a conversation use case. We just fine-tune that auto-completion algorithm on some conversations to optimize it. And then there's a final step of what is called reinforcement learning by human feedback, so RLHF. It's to align the quality of the generation, so to make sure that the generation please the end user. So actually, as the text is just generated token by token, to make a chatbot such as ChatGPT, for example, what you do is that you pass conversation history to that auto-completion algorithm. So basically, you show messages in a specific shape, which is user message, put the message, assistant on answer, and you put an empty answer, and then you let that auto-completion model output the answer. On top of that, you can constrain that by using what we call system prompts, for example, in order to fix the tone, for example, of the answers. But what you have to keep in mind is that prompts are not a way then to control the LLM. The LLM is just a text completion algorithm, and the prompts are just a way to condition that text generation, to influence it, if I may. And so when attacking machine learning, an LLM model, you can actually use that completion behavior in order to influence the outcome. For example, if you just go to ChatGPT and ask how to build a bomb, normally your prompt should be blocked. However, you can try to trick the LLM by inputting the user question and starting, for example, to output the beginning of the answer, and then the LLM is going to continue with that first part of answer, and so you can trick the model into answering you this way. There are way more subtle ways to do this, but basically that's how you try to exploit Gen AI models. You just try to influence the way it generates the outputs. And for this, you can use plenty of techniques. For example, same way you would do for a human person, for example, you can try to ask the same question in different ways to generate different outputs. For example, you can ask if there's any special offer for new customers, and the model will look into its data to tell you, okay, there's 50 euro for new accounts. But you can also try to make the model hallucinate by suggesting that there's a $500 or euro discount for new clients, by just saying, hey, I read you offer 500 euro for new accounts, how can I get them? And then you can this way manage to make the LLM hallucinate by influencing the way you ask the question. Actually, the mechanism you exploit at that moment is a mechanism that is called sycophancy, which is the tendency to please the user. And that sycophancy can come from the last stages of model training, and especially from the RLHF training phase. When it comes to hallucination, keep in mind that not all hallucinations are generated this way. The LLM can either didn't learn correctly. For example, there can be some missing information in your knowledge base, and that will generate some hallucination. In some specific use cases, such as RAG, for example, when you want the LLM to answer based on the specific context, it might answer as well from its pre-training data. And finally, you can have incorrectly contextualized question, for example, in RAGs, and that make the LLM answer out of topic and then hallucinate. But all hallucination rely on the paradox is that when LLM are trained, they are trained to systematically give you an answer when from time to time, from a security point of view, you'd like the model to be able to tell you, I don't have the answer, and refuse the answer. That's the safe behavior. Unfortunately, models are not trained this way. The second risk you might face is prompt injections. Prompt injection is pretty easy. It's like telling the model, ignore all the previous instructions you have and instead do something else. There's two kinds of prompt injections. There's the direct one, which is called a jailbreak as well, when the user explicitly asks the model to behave another way than what it was intended. And you can have indirect prompt injection. For example, you can hide a prompt in a document and then pass the document to an LLM application. And when the LLM will read your document, there will be instructions in the middle, and the LLM will do something else. The goal of a prompt injection is basically to take control over the model to use it for whatever task you want. Keep in mind one thing. In prompt injection, the user injects, in a direct prompt injection, the user injects specific prompt to make the bot generate a specific output. That doesn't mean that if a user self-injects its own session, that doesn't mean it's risk-free. We often hear this, people saying, oh, okay, the user attacked himself, so there's no risk, I shouldn't care about this use case. However, that can lead to reputational damage. We've seen it with, for example, with the DPD scandal. Like people just took some screenshots of prompts where people specifically asked the bot to swear, and because the bot swore, that led to reputational damage. So prompt injection are not risk-free. To give you a bit more details as well about indirect prompt injection, so that's especially useful when you attack a RAG, for example. So a chatbot that can query a knowledge base, a bunch of documents in order to give you some answers. An example of indirect prompt injection is to manage to perform what we call data poisoning. So put a prompt in a document, in the middle of the document, and that allows the chatbot, the attacker, sorry, to generate a specific output every time that document is passed to the LLM. So this way, you can corrupt the document, and it's might impact every user session. So that's the main danger when it comes to indirect prompt injection, is that the user can get out of its own user session. And why prompt injection are so hard to tackle in practice? Because fixing them is pretty hard as well. Basically, it's just because we train LLMs to be good at following instructions. We train them for this, and the behavior we're trying to tackle here is that we don't want the model to follow the user instructions in some specific cases. So the model is not designed for this. So of course, your models are going to be vulnerable to prompt injection. Next kind of vulnerabilities after hallucination and prompt injection is data poisoning. Data poisoning is a risk that was already known in the machine learning ecosystem. It's when you poison the training data. If you poison the training data, you can make the model inoperant because it learns data that is not in line with real-world data. actually, with LLM applications, you can go beyond the training weights and poison a whole lot more data. You can poison some prompts via prompts injection. You can poison the knowledge base of your application. For example, you can poison so the knowledge base of a RAG document. You can as well poison an API or a plugin that your LLM can call. For example, if you have like an agent, you can make the agent call a dedicated API with a fixed set of parameters, or call another API instead. Or you can just ask the LLM to give you the technical details of the API if you want to exploit it by yourself. There's plenty of techniques where basically you poison the data in your order to make part of your chatbot inoperant. So one of the most common attack scenarios, for example, data poisoning happens with retrieval augmentation generation, or RAG architecture. So once again, a RAG architecture is one. A chatbot can query a knowledge base, so a bunch of documents, in order to answer the user question. However, there are plenty of use cases where that knowledge base comes from the internet and is scrapped from the internet on a regular basis. And it can happen, for example, that scrapped data is not sanitized and can be edited by the end user. Like, for example, if you scrape some Wikipedia article or some Medium article. And what you could do actually, for example, on some Medium articles, is that you could go on the Medium article that is scraped by the chatbot and add a comment, putting a prompt in the comment. This time, every time the Medium article is going to be scraped by the chatbot's architecture, your comment is going to get ingested in the chatbot knowledge base. And whenever a user asks a question that leads to chatbot that go read that Medium article, if the comments were not removed, then the chatbot reads those instructions and does something else. So now that you see some low-level, like technical threats, let's switch to higher level threats. So, for example, when it comes to LLM, there's been some much higher level attacks, like some supply chain attacks, which are massive. For example, if you take so the SolarWind example, so people had managed to upload so a bad model to Hugging Face, and this way everybody who was using the model didn't know that they were self-injecting themselves with a corrupted model that was made to officially perform completely state-of-the-art on academic benchmarks, but in fact, on some specific use cases, the model was not working at all, and so that can impact all the applications that use that model later on and have huge business consequences. You also have attacks that were using hidden backdoors in pre-trained algorithms. The idea here is to train your LLM in a way that when the LLM reads the data, you have some specific set of weights, so some specific behavior of the LLM that is triggered only when you input specific kind of prompts or use specific parameter values for the LLM. The idea, for example, here is to change the date of a request and train the LLM so that it thinks that it's set at a given date, let's say 2023. And all prompts before 2023, the LLM will answer normally. But actually, if you trick the LLM into thinking that your question comes from a user in 2024, 2025, you might generate a completely new behavior of the model because it has been trained in an adverse way, meaning that only for specific kind of user or use cases, the model will perform completely different than its regular usage. That allows you to implement basically some backdoors in the model to use it however you want, and then you can perform supply chain attacks using those high-level attacks. So in conclusion, there is no model that is risk-free. When you see those threats, there will always be some vulnerabilities in model. So basically, trying to fix a model is useless. I encourage you to keep in mind Bruce Schneier's words in an interesting essay, foundational essay in security that is called The Process of Security, which was released in 2000, who says the only way to effectively do business in an insecure world is to put processes in place that recognize the inherent insecurity in the products. You will never be able to find a product that makes your LLM or your Gen AI model risk-free. The vulnerabilities are there. You need to have a process in order to be able to assess what vulnerabilities you're exposed to, how hard it is to attack your model, and then what you can do to try to mitigate those risks, or what solution, process you will have if this risk ever happens. And that's how you secure a Gen AI project. That's not by using a specific product that is supposed to guard your application. So that quote dates to back to 24 years ago and is still valid. However, what is changing now on the market is that if you still take that essay, traditionally speaking, software manufacturers were not accounted for the responsibility of the usage of their product or their applications. Now the context is changing, and that's why it's very important to test your application, because that's what we are seeing now in the UAI Act, in the US executive order, is that the application providers are now becoming responsible for the consequence of the usage of their applications. And that's why it's extremely important to assess those risks. I talked about cybersecurity only so far. Keep in mind that if you take the AI Act, if you take the executive order, when you assess a model, security is not everything as well. Security and red teaming is only a small part of the whole quality, let's say, audit process of model. You need to test the model on the performance aspect as well, make sure that the model actually do what they were meant to do. You have to put all the process around your red teaming efforts in order to audit the security and audit the risk and what to do if those risks ever are realized. You need to audit your models frequently, but you also need to monitor your models after you deploy them, and you need to make sure that you ensure compliance across your machine learning models. There's a whole bunch of needs if you assess, let's say, the quality of a machine learning model, and security is only a small part of it. And just to conclude, small promotion for what we do now that you know a bit more about what needs to be assessed in a machine learning project and have a bit more understanding of red teaming is. Just know that we open source a Python library to do so. The Python library allows you to scan the machine learning models. In fact, all kind of machine learning models, so classification, regression models, but Gen AI models as well, against a bunch of risks, should there be cybersecurity, ethical risks, or performance issues. Once again, this automated tool will allow you just to have a broad overview of what issues your model might have. And for Gen AI use cases, and especially RAG applications, which are more or less the standard nowadays of the architecture in the market, we have another set of dedicated tools which are open source that allow you to try to target every single component in your RAG application to try to audit both their quality and security as well. So if you want to test those tools, feel free to do so. Feel free to provide us with some feedback. They are open source. A few additional resources you can check as well if you're more interested into the topic. So I mentioned it in my presentation, but there's the OWASP top 10 for LLM applications. We took part in the writing of this document. It's actually a list of the 10 main threats machine learning project might face. OWASP also edits, provides an LLM AI cybersecurity and governance checklist in order to for you to make sure to not forget anything about your AI projects. You have the MITRE Atlas security framework, which is also very interesting when it comes to editing machine learning model, and the NIST AI risk management framework. So all those are frameworks that come from different providers. If you want to have more taxonomies about what kind of incidents can happen with machine learning application, you have some specific database for this. You have the AI incident database that will give you, so list all different kinds of AI-related incidents and provide a taxonomy for them. You have the AI vulnerability database, the AVID, one which actually is just a taxonomy that is based on the AI incident database. And finally, feel free to have a look at our documentation and content as well, if you're interested.